But so what happened is people got really tired of, oh my goodness, there are so many different kinds of normal curves. They all look very similar. They're all bell-shaped. They're all symmetric. They're all slightly different. And people said, I don't want to deal with this. So what they did is they came up with a formula, and that was that Z formula we covered back on test 1 in chapter 3. And what it does is it standardizes everything. And it's called the standard normal distribution. What it does is it turns everything into the exact same bell curve. So I'm not dealing with a whole bunch of different bell curves. I'm just going to deal with one and worry about that one. And that one bell curve will take all of our values and turns them into Z's. And on our Z picture for our bell graph, instead of always having the mean in the middle and every mean being slightly different, it says, okay, well, if I've got Z's, I'm going to turn all means to just the number 0. So I'll think of, if I've got a Z value, 0 is what goes in the middle. And then our standard deviations will just be 1 unit. So 2 standard deviations. So 2 standard deviations is just going to be at the number 2. 2 standard deviations below the mean will just be at the number -2. So each standard deviation is just 1 unit. Just the number 1, the number 2 is 2 standard deviations, 3 is 3 standard deviations, and so on and so forth. Now, because 0 is in the middle this time, it cuts our picture in half. We know, remember, they told us that all of the area under these graphs have to add up to 1. Why is that? Is because, remember, the areas work just like probabilities, so that they have to add up to 1. Okay, what does that mean if I only want to look at, let's say, half? Either the right half or the left half would just be half of the area. Well, if the whole area is 1, half of it would just be 0.5, so half is to the right, and half, the other 0.5, is to the left of 0. But this kind of gives you a good idea of what kind of picture we're going to be working on and looking at. So what we're going to be looking at is being given a Z value and finding an area or a probability. They'll mean the same thing. How are we going to do this? You can do it one of 2 ways. You can either use your calculator, and last time when we did areas or probabilities using our calculator, we had a binomial distribution. So we did a binom PDF. This time we have a normal distribution and we're adding up areas, so we're going to use what's called a normal CDF. The reason why the CDF this time and not a PDF is the C stands for cumulative. We want it to go ahead and add up the probabilities for us. And we're going to get to it the same, it's underneath the same menu as the binom PDF, where we hit the second button first. It's usually a yellow button on your calculator. And then you hit the vars or distribution button second after that. And then we're going to be choosing, we used to go down all the way down to 0 to get the binom PDF. You're only going to stop at normal CDF. The question is, how do you use normal CDF? Well, as of right now, if you've got a Z value, normal CDF only needs a start and a stop, a left and a right side. And it will find all the area or probability in between. So if we have, let's see, a normal curve, and we have a start value, and we have a stop value, we can find the area in between those 2 values, or the probability in between those 2 values, using this normal CDF And what we'll do is we'll do the normal CDF, and we're going to read it like we normally would a graph. We go from left to right. So you always have to give your start value first, then your stop value second, because you're working from left to right. So you'll give your start value first and your stop value second, close it off. And as long as these are Z's, your start Z and your stop Z, it will just go ahead and split out the area or the probability for you. It's really handy. So if you look at this example here that we've already got done, the normal CDF of -1 to 1, what it's doing is it's taking a Z value of -1 and a Z value of +1, and it's calculating all the area or probability between the two, which is 0.68. So our probability or area would be 0.68, or as a percentage, 68%. Sometimes they'll ask for the probability or area, sometimes they'll ask for the percentage. But you should become very comfortable with using your calculator to do this. Let's